Hey guys, for anyone who's watching this, I'm just going to record a small interview for showcasing my skills in Python. So let's get started.
Great, Arjun. Let's dive right in. To start, can you briefly explain the concept of Python decorators and how you've used them in your previous roles?
Sure. Python decorators are a way to manipulate existing functions to add new functionality or inject functionality within that. So one of the key places and the most repeated places that I've used decorators for is for logging. Now, the place where I've used it the most is, let's say, I have a class function in which there are multiple. I mean, I have a class in which there are multiple functions, and I wanted to do like logging for all the functions in there. What I would do is I can do decorators on each function, but alternatively I can just apply this decorator through a loop as well on all the functions that are listed inside it as well. So that's how I've used decorators for the most part. If I'm not wrong, the right word is called metaprogramming, in which we access the class objects, the class functions as through an iterable loop. We can apply the function on top of it, and technically it becomes code that has been injected into a class that has already been defined.
Absolutely. That's a solid explanation. Using decorators for logging is a common and effective practice. Building on that, let's talk about error handling. How have you employed decorators for error handling in your projects, especially in a production environment?
Great question. So when it comes to error handling, one of the primary things that we need to focus on is giving out enough information about where the issue occurred. So that would mean printing out, let's say, the log line, the timestamp, so that we can sequentially sort it out. And these are two things. And apart from that, we also need to ensure that exec info is set to true. This is one key important fact that I tend to see that people tend to miss out on, because if we don't enable this inside, let's say, a try-catch block in which we are doing an error log, what would end up happening is we can see the log line that's being printed for, let's say, this error occurred, but it won't give us like a proper traceback of what went wrong over there. So exec info set to true, logger.error with the relevant log line coming out, and wrapping a function in a try catch that has all of this enabled is basically one of the easiest way to do error handling with the decorator.
Spot on. Using excinfo equals true indeed provides valuable context for debugging. Now, considering your extensive experience, let's take it up a notch. How would you design a decorator to handle both logging and error handling, ensuring minimal code repetition across multiple functions?
Okay, so to begin with, I would define the first line of course, the decorator would be to mention the function name that it's being called, that's being called. So let's say function called run is being executed. The first line that would say run was executed is one of the logs that I would do, and at the bottom of the decorator, let's when the function is about to exit, I would put like run function has exited or completed successfully. With That's one thing I would do, and with that I would also do like a start and end time as well, to just give out small traces of how long does a function execution really take. This is more of a good to have, not like a mandatory thing. Once these two parts are defined, what I would do is add in the try catch block over here, and then put in the whole function calling in here basically. So that way what happens is, within the try catch, I can actually do I can actually go through the function, see if it works as expected. If there were any exceptions that were raised, I can ensure that exec info gives the relevant info, and the logger error would give me the actual function name, and where this whole file was, where this error occurred. All these information could be piped in through that, and yeah, that's how I would go about it.
That's a comprehensive approach. By combining logging, execution timing, and error handling into a single decorator, you're ensuring a robust and reusable solution. Now, considering your experience in MLOps and data science, how would you modify this decorator to handle functions that deal with data processing, especially focusing on maintaining data integrity and privacy?
Great question. So, in most of these decorators, like when we're trying to do some debugging, what we end up printing out is a lot of the variables that are going in and out and everything. One of the biggest problems with when we're dealing with data is that some of these variables might have potentially sensitive information, and ideally, you don't want to log it out just in std out. So, what I would do is within the same decorator that we have, uh, all the keyword arguments or the positional arguments, whatever are coming in, I would pass each of them through a PII detector, and also a function that can be run to obfuscate it in such a way that it's a one-way obfuscation. And like there will be some sort of an identifier which we can look it up if needed, but by default, like this function would go through all of the variables that are being, possibly printed before the actual function gets executed. And that way we have deeper understanding of, like, what set of data caused this error to fail, sorry, this function to fail. And also same thing goes around for the return values as well. Like in the log lines, ideally there should be no sensitive data coming out. So this PII detector and obfuscation logic can be a part of this decorator itself.
That's a great strategy for handling sensitive data. Integrating a PII detector and obfuscation logic into the decorator ensures that you maintain privacy while still capturing useful debug information. Now, looking ahead, how would you apply this approach to a machine learning model deployment pipeline, particularly focusing on monitoring model performance and catching anomalies in predictions?
Great question. So, when it comes to finding anomalies in predictions, like to begin with, these models, like, they would have some sort of a train and test set. So, what I would do is, like, for all of these models that we are like trying to do evaluation on, and that's going to be like a constant evaluation. So, what we would do is, to begin with, we could have like evaluations on the model itself, where like it does tests against this test set basically, which has the labels in which we know for a fact that the predicted answer should be the correct one. And if it starts deviating over time with, let's say, new releases or something that are coming in, then we raise an alert and send a flag. Flag down the person who has deployed it, and notify them that, like, this latest release, or let's say the current model has drifted, and it's just not working the way it used to. So that's one way to go about it. Apart from that, let's say when we're doing prediction, like online prediction, like let's say it's like a daily thing where if let's say we're taking in an input image and we have to return what is present in the image, let's say classification. In that case, what I would do is like I would tap into the user feedback as well. So if, let's say, a transaction comes in and we make a record of that, and after that the user is sending feedback like this was a bad prediction, then we could compare and see like where it went wrong and highlight that as an anomaly. Apart from that, we can also have like an anomaly detection system as well. So one of the versions that I've used is, in fact, uh, Kibana, sorry, not Kibana, the elk stacks anomaly detection. So if, let's say, randomly out of the blue you're getting like thousands of it, or like, way too many requests from a specific IP address or some specific source or whatever be the case, there are multiple factors on which you can define anomalies basically. So yeah, to start off with, you can do like source based anomaly detection to see that just one person is not trying to hit too many times, and you could end up rate limiting them if needed. But that's one of the ways that I would go about this.
That's a comprehensive approach to monitoring model performance and catching anomalies, leveraging both model evaluation with test sets and real-time user feedback ensures a robust system. I'm curious, given your background, how do you see the role of Python evolving in MLOps and data science in the next few years?
So honestly, I'm not quite sure how long Python is going to be around, especially when it comes to MLOps. Of course, it's not going to go away entirely because it's very easy to read, and the package support is amazing. Like pretty much any machine learning library or data science or deep learning library that you think of definitely has a Python implementation. But when it comes to scale and the cost of inference and all these things, and of course the inference time as well, Python might not be the best solution out there. I mean, I would rather prefer to do Rust based inference server or something like that. But of course, for POCs, like for workloads that don't have too much load, or we don't really need $1 million, sorry, not $1 million, millions of users of scale in very little constrained compute environments. Python works great for sure, without a doubt. And of course, if you're using fast API and with a UV server, sorry, you can serve to like a lot of people for sure. But yeah, Python is not necessarily the best for long term deployments and scale and everything.
That's a fair assessment. Python's readability and extensive library support make it ideal for prototyping and development, but other languages might be more efficient at scale, especially for inference. It's been great hearing your insights, Arjun. Before we wrap up, do you have any final thoughts or predictions about the future of Python in the tech industry?